Today in class, we really didn't develop a formal way of solving it. We didn't develop a step-by-step way of solving this process, but we developed a way of thinking about them. That way of thinking will result in a more structured approach, but right now I want your brain to try and get a handle on exactly what is going on within the problem. Try and make sense of it. For instance, this problem states that there is 8 times some number plus 7 equals 31. The way we looked at it in class was, well, let's try a simpler problem. Let's just figure out what has to be added to 7 first in order to get 31. And in class we talked about the fact that, well, what our brain does is it takes 31 and subtracts 7, and we reach an understanding that the number 24 has to go in there in order to make this true. What is in there now is an expression, 8n. A number has to be produced as a value for n such that when we multiply 8 by it, we get our desired 24. And what our brain is doing that we talked about in class, well, our brain is taking 24 and going divide it by 8 to figure out what we have to multiply by to get the 24. And what happened was we divide 24 by 8 and we get 3. And now we have an understanding that if n equals 3, 8n will equal the 24 we are looking for. In order to check it, just like with peanuts and 4 friends, we put it back together, whether it's quickly in our heads or whether it's on paper. We check to make sure that 8 times 3 plus 7 is 31. 8 times 3 is 24 plus 7 is 31. So it's a lot of computation in your head or computation on the calculator, but I'd like you to get this idea that we're undoing this problem. We subtracted 7 from 31 to get 24, and then we divided by 8 to get 3. That was backwards. Forwards to the problem is taking 8 times 3 and adding 7 to it. But going forward is how we perform our check. So no matter what problem we're working on, we may want to take whatever term has the variable in it and write a simpler problem first. So for instance, what number has to go in here such that when we subtract 1 from it, we get -2? Well, in order to understand that, we have to add 1 to -2 so that we know what number, when we subtract 1, we get -2. And we understand that this number now has to be -1. -1 minus 1 gives us -2. Start at -1 in the number line and go 1 more in the negative direction for subtraction. So -1 minus 1 is -2. Now we understand that this piece has to be -1. Well, we know that 9 divided by 9 gives us 1, so we gain an understanding that if m is equal to -9, then m divided by 9 should give us the -1 we're looking for. Now, we may not be real happy or real sure about our answer at this point. That's why the next step is so important. Does -9 divided by 9 minus 1 give us our desired answer? Well, -9 divided by 9 is -1 minus 1 is -2. I start at -1 and I subtract another 1 from it and I get -2. So this whole blob approach may look very unstructured and it may look unmathematical, but it really takes what your brain does naturally and puts it into a pseudo process. So try your best with these problems, check your answers, and then we'll come up with kind of a list of methods or a list of things that we do every time that we do these problems, and we'll have a more formal structure to our work at that point.